Well, I haven't worked on a radio for a little while. I've been doing some other things, but this one came up on Kijiji recently for a pretty good price. And usually when I see these late 40s, early 50s tabletop tube radios, I almost always buy them. I have a couple of rules. They have to have their knobs. This one has its knobs, and it has to have its back because that's where the antenna typically is. So this one has the knobs in the back. Unfortunately, it also has a very nasty crack up here that went all the way down here and has been, wow, that is really something, and has been really poorly repaired. So I'm not sure whether we'll be able to do anything with that or not, but at least we can take a look at inside of the radio and see what it's like. So this is a RCA Victor 65X1. They first started making these in 1946. So this one's probably a 46 or a 48, somewhere around between 46 and 48, I would guess. We'll take a look at it. We'll take it open and we'll see whether there are any date codes inside. So first of all, obviously this power cord is completely shot, so that's going to have to be replaced, but that's not unusual at all. The back's a little bit warped. That's missing one screw. Again, not uncommon. No, lots of dust inside. So we'll pop it open and see what we're dealing with. Before we take the back off, so let's take a look at the label here. So on the back it says Little Master. So often these models have names like that. Actually, there's probably quite a few that are Little Master. And we have our CSA approval stamp. That's good to know. And we still have a little bit of the original tube chart. So this is like most of the radios I work on, this is what's known as an All-American 5 circuit. It has no transformer, but it has 5 tubes in series, and the filament voltages add up to around 120. So in this case we have a 12SA7, a 12SK7, and a 12SQ7, so that's 36 volts, and then a 35Z5 rectifier, so that's 71 volts, and then a 50L6 power tube, that's 121 volts. So if you have your filaments taking up your 121 wall voltage or thereabout, you don't have to use a transformer. So they saved a lot of money by using that design. It also made the radio much more dangerous. Okay, so I had to take the knobs off, and we're going to slide this right out, and I can see right away that it's very dusty. Yep. So the first thing that we'll do is we'll take those tubes out and test them. The good thing, ooh, look at that, cobwebs. The good thing is that the speaker, now I've said this before, speaker looks fine and then it turns out to be not so fine. But that one looks fine, and the line cord is good. So you can select your channel. The on-off switch works, power switch. So we'll test the tubes. We'll change the power cord. We'll take a look at, let's take a look under here and see what we see. All right. So looks like these may be the original caps. RCA Victor. What's the date code on that? Yep, original. So that's got a May 1946 date code on it. So these are all original, so these are all going to have to come out. Not sure about this one though. I bet you that's a replacement. Looks like it. Looks like there's been some non-factory work done in there. I don't think it's very rare to get a radio of this age that's still around that hasn't been worked on at some point. So anyhow, it doesn't look too bad. It's a bit of a tight squeeze, as sometimes these do tend to be. We'll have to replace this capacitor, and we'll see what we end up with. Well, this is interesting. So we'll start testing the tubes now, but I noticed the power tube, which was supposed to be a 50L6, has been replaced with a 35L6. Similar specs. Of course, it's a 35 volt filament instead of a 50, but there was so much variation in line voltage back then that it probably didn't make much of a difference. So anyhow, we've got the tube tester. This is an ICO 667, all set up to test. I've got it set for this particular tube. We'll put it in, let it warm up a little bit. Yeah, if the filament does warm up. Not seeing anything, might be dead. All right, well, let's give it a try. So, let's see. No, that's good. No, that tube is dead. So there's your first problem. We'll have to. I've got I think a few 50L6s we can use as a replacement. This guy did not survive. Okay, so let's take a look at the schematic, and we have it here for the RCA Victor 65X1. It's a pretty straightforward, common, all-American 5-tube radio. They usually look like this, and you can see here is the filament voltages of the 4 tubes in series, from the rectifier being the 5th tube, of course, going to ground. And then also we have, one thing that is unusual about this schematic is it's quite detailed in terms of providing voltages. So you can calculate gain, and you're supposed to test it and make sure the gain is correct from each stage and so on, with a 3-volt fixed bias. That's kind of unusual. You usually don't see that much detail. And then down here we see that there have been some revisions over time with C17, this capacitor, which originally went from the plate to the cathode of the 50L6 power tube. And then there was a revision that went from the plate and between the output transformer and the suppressor grid, and then finally from the plate to the output transformer, and then its own sort of ground. So let's take a look and see if we can figure out which version we have, the original version, or the first revision, or the second revision. So here is C17, a 0.02 microfarad capacitor, and in this particular version of the radio, it is between pin 8, which is the cathode on a 50L6, and the plate, pin 3. So this tells us that this is the original version, the non-revised version of this radio. Exciting, eh? So I'm going to be cutting off this power cord, which we'll have to be replacing, and then I will gradually, one by one, go through all these capacitors and replace them. And this is the old rubber covered wiring. Usually that dries up and cracks. This doesn't look too bad though. Anyhow, doesn't matter, we're going to be replacing it all regardless. So we'll take a look at this capacitor and we'll see if we can get a date code off that, because this one I don't think is original, so that'll tell us when the radio was worked on. And away we go through the magic of video. So that mystery capacitor is a 0.1 microfarad. It might be a 1961 date code. That would make sense. Like I could see after about 15 years, your capacitors start to go, but it's strange that they only replace this one capacitor. But if you can see here, that solder job, that's clearly not factory. So this was definitely added after the fact. So we have removed the electrolytic capacitor. This is the power supply filter capacitor, or capacitors in this case. And you can see the date code on it. Wait a minute, where to go? So May 1946. So it's probably long dead, but I've been surprised before by these capacitors. A typical life of a capacitor, electrolytic capacitor like this, would be about 15 years before it would dry up. And this one's been in that radio for, what, 73 years. So let's test it. And we'll be testing both for capacitance and leakage with my little cheap tester here. And I'm not quite sure which is which here. One of them, so this is a dual capacitor. One is 50 microfarads and one is 30 microfarads. But of course the color codes have long since faded away, so we're not sure what's what, but we'll give it a try. So first this one. It's taking its time. So 51 capacitor, 51 microfarads. So that's pretty good if that's the 51. Let's try the 30. If this is the 30. And there's no leakage showing there. It didn't test for leakage for some reason. And that one has a leakage of 2% and it's 62 microfarads. So they're both reading above their rated capacitance. So you know what? You could probably have used this. I could have probably have left this in the radio, but you know, who wants a 73-year-old power supply filter capacitor? So anyhow, we replace that. So we have replaced all of the capacitors. There they are. 1, 2, 3, 4, 5, 6, 7. And in fact, there were two that looked like they were replacements. This one here, which was probably from the 60s. And this small one, that's a 0.01 microfarad, that's completely a different style. So there they are. There's the new polypropylene capacitors in there, and I replaced the electrolytic capacitor with two electrolytic 50 microfarad 160 volt capacitors. So I think all that we need now, oh, and I've also replaced the power cord. So all that we need now are some tubes, and we can give it a first test. But you know what, I have a ton of 12S K7s, and I have a few 12S A7s. What I really need are 12S Q7s, and all I have is this one really weak one. And of course I'm also going to have to find a 50L6 power tube. Power tubes have a tendency to blow, but I don't see any in my collection, so I must have, I may have to steal some from one of my old radios. Okay, so let me describe the safety setup that we have here. So the radio is plugged into a current limiter, which is in series with this light bulb, so that if there is a short in the radio, the light bulb will absorb some of the current and we won't have a huge explosion. The current limiter is plugged into a watt meter just for fun. The watt meter is plugged into this variac that will help us, that will let us control the voltage. The variac is plugged into a isolation transformer, so to reduce the possibility of a shock. So that's the setup, and let's see whether we can get that radio working. So the radio is turned on now. We're just going to turn some power on. We're just going to give it a little bit of voltage, and we will watch for smoke. It's up to 60 volts. I see that the pilot light is starting to come on. So that's, at least that light's not burnt out. Just let it sit at that for a second. And now we're up to 90 volts. Somewhere around here we should start hearing or seeing something. Nothing yet. There we go. Starting to hear a little bit of sound now. So we're up to 108 volts. There's only really one AM station that you can get around here. Let's see if we can find it. I might have to do an alignment. It's usually, it should be up here somewhere. Of course, some of those tubes are very weak. We're not going to get much in the way of reception. Oh, there we go. That's not bad at all. Success. There we go. So I'll just do an alignment, and that should take care of it.